Hello, this is Eddie, Lima United 2 Delta Kilowatt Tango again. Perhaps I met some of you on 160 meter, my favorite band, okay? I am using my Curaset.com picture to avoid touching the camera. After the other three YouTube videos showing what happened when we tried to measure CW or single sideband PEP output power with conventional voltmeters without real PEP capability, I was asked about which was the maximum PEP output power that the modified Alpha 76 was able to deliver, and also there was interest in knowing which modifications I applied specifically to it. My English is limited, but I think that trying on it I could help or reach more DX people, so I will try to do my best. By the way, if you didn't see in the other videos, the ones that are on YouTube, perhaps you could also be interested to watch them. They are in Spanish, but you can use subtitles, as a friend of mine suggests, as a YouTube option, and you can run the subtitles in your own language. Look for them with my call sign. Look for them with my call sign, Lima United 2 Delta Kilo Tango. I think also they are called PEP versus average power or something like that. Even though there is a lot of information about the mods on the internet, and there is nothing new on the mods I did to my friend amplifier, some friends insisted on to explain them in a compiled video. I will produce two videos then. In this first part, I will explain all the mods I applied to it with pictures, and on the second part, the idea is just to show you the amplifier running on 80 meters full power. We will be watching at this PEP output power, PEP voltmeter, and its waveform shaped in an oscilloscope. I will do it first on CW, then on single sideband voice, and finally on single sideband but passing a two-tone test. Have in mind, this video is not intended for the expert. They already know all of this and even more. It's just for hams with some knowledge in measuring equipment and measuring equipment in electronics, and also for those trying to learn more about amplifier modification and basic amplifier testing. Okay, so here we go. Let's. This is the real modified Alpha 76A. This is a friend amplifier, okay? This amplifier originally came with two tubes. This one, let me try to show you. These two tubes. This one are 3CX800 or 8874 tubes, okay? What I did was just modify it with a pair of 3CX800 that were both in the USA from pull-up, so they are not new, but they seem to be in a good shape anyway. I read many suggestions that can be found on the internet, but basically what I did was the following. Okay, so pay attention to this box that contained the two tube socket. Okay, the first problem with this is that there is enough space for accommodating the 3CX800. Okay, so this box needs to be modified. What I did, I just cut up the top of the box and place an aluminum plate, okay, with the new two holes to fit the two 3X800 socket, enough apart to do not touch each other, also to accommodate the two new king-size chimneys. Okay, you can see them; they are homemade, and also there is left some space between them. Some other models come with three tubes. There is another tube around this place, okay? So in that case it will be much easier, because the only thing that you can do, because you can place the 3X800 on these two places and just put a plate to avoid the air to go off from this hole, huh? Just to this hole with an aluminum plate, okay? So you can see, as you can see here, okay, this picture with the two tubes in place and the connecting wire. I will talk about then a little bit on when we talk about the output power, about these connecting wires, okay, and this cap. Okay, another mod that had to be done is that we need to change the filament voltage of the for the 3CX800. The 3CX400 run with 6.3 volts, but the 3CX800 run with 13.5. So you can do a couple of things. One of them is to use a completely new 13.5 volt filament transformer. What I did in order to save some space is just I use a 7.5 volt AC, which added to the 6.3 original one, provide the 13.5 volt AC for the filament at 3 amps continuous. Okay, this transformer, this one particularly, has some taps on the primary, so I can adjust the 13.5 exactly at the tube socket. On this picture you can see where I place this transformer. The rectifier circuit board is removed, it's on top on this place. Okay, I just remove it just so you can see it. So I place the transformer on this wall, this vertical wall that separate the power supply compartment from the radio frequency deck. This is the front panel. You can see the two measurement instrument. Okay, and we will talk about this new bank capacitor. Okay, let me change this one. You can see how this amplifier came to my lab. There was some problems with the power supply. Okay, you can see that there was a missing capacitor with 2 wires and a capacitor with the tape here, and also there was some fireworks around this place. You can see that. So I decided to obviously to improve this, but not only just to change for the original, but to improve a little bit its capacitance, the bank capacitance, and the isolation voltage. What I did was the following. I used 2 rows of 7 220 microfarad capacitor with 450 volts isolation. So there are 2 rows, 7 in series, and I parallel them, totalizing around 63 microfarad approximately, at a total of 3150 volt DC isolation. Okay, with that isolation we can run all this capacitor at about 70% of a maximum isolation capacity, which is recommended by many authors. Okay, so you can see the picture here. Let me change it here. Yeah, I did it very, very simple. The circuit board is very, very simple. Here you will find in another picture there will be placed the drain resistors across each of the capacitor on each side. Okay, and you can also see the same picture now with the transformer in place and the capacitor bank fixed to the bottom of the Alpha 76 chassis. Okay, before and let me see if I have a picture. Yes, now you have the rectifier board on top of the transformer. The transformer is below this side, and the capacitor bank is below this side, and you can see the 2 wires coming out from the capacitor through the circuit board. Here is the red wire with the positive of the capacitor, and the black obviously with the negative side of the capacitor. Before I forget, because you can see that I removed the drain resistor here. I removed all of them and I placed them on the capacitor bank. You can see you have a picture. Yes, I have a picture from the side of the amplifier. This is the front. Okay, this is the front, and you can see on the back the transformer. You can see the transformer on the back. The capacitor bank here with each of the resistor for each capacitor on each side of the total bank. Okay, before I forget, Now let me show this one just to okay, before I forget, because I don't have a picture for this, I also modified the DC plate meter full escape indication, which normally comes with 1 amps full escape. I modify it and double it. So now the full escape of the plate DC meter current meter is 2 amps. Okay. For doing that, I simply use 2 1 ohms resistor, 1 watt, 2 1 ohm 1 watt resistor in series, and I just tap the meter in one of them. Okay, so I place the 2 resistor in series. On each end I use the normal connection, and I tap the meter across one of the resistors. I don't have a picture, but it's, the modification is simple, just to avoid the needle knocking at the end of the meter. Okay, so let's go back. Let's see. Okay, well, let's talk about a little bit this mod. Okay, according to AMAC, the 3CX800 specification running in AV2 cathode-driven configuration, each tube should present around 54 ohms of input Z. So, being 2 tubes in parallel, they should be close to 27 ohms. Okay. The toroidal transformer connection modification, this is a mod that you are going to find on internet, is known as low drive modification for this amplifier. Okay, with this configuration, it will transform the 22 ohms to 50 ohm as input to the transceiver. Okay, so you're going to find this mod. Pay attention to this announcement here. I will repeat it again shortly. And you can see the transformer connection. So the 2 tubes will present around 27 ohm. With the 100 ohm in parallel of those 27, you will have around 22, 23 ohms for the transformer to present it to 50 ohm to the input. Okay? This amplifier came with 2 rows, or with 2 rows of 470 ohms. All the resistors are in parallel. Okay, all resistors are in parallel. So what I did in order to get the 100 ohm, what I did was just to remove one of the rows. So one of these rows, I just remove it. At a particular one, I remove this one, and I let the back is the same. Okay. So one thing that's to comment on this is that, as mentioned before, do not run the amplifier without at least 1 row. Do not do that. Okay. So after this mod, to improve the input SWR, what I did was just to measure it. Okay. So I just disconnect the coax coming from the relay and put a short coax with the analyzer, the SWR analyzer. Okay. So what I found out is that the SWR was close 1-to-1 from 160 meter and 80 meter, and start raising slowly from 40 meter on towards the 10 meter band. Okay, so it reached on 10 meters to 1.8, something like that. What I did was just, without the tube in place, I put the 27 ohms, simulated the tubes. Here you can see them on the back. As a matter of fact, there are 4 27 ohm resistors. There are 2 in series with 2 in parallel, because I use this load with the capacitor to cancel out the reactance. I use this load for testing volumes and things like that. So I just already have it, so I use it. Okay, so with this configuration, without any mod, you're going to have low SWR on lower band and raising slowly, starting on from 40 meter on to 10 meter. I found out that placing a 120 PF capacitor in parallel with the resistors, here you can see on the top and on the ground, to ground, the SWR could be improved. As a matter of fact, with this capacitor in place, the SWR indicates 1-to-1 from 160 to 10 meters. Okay, I didn't let this particular capacitor in play because I just wanted to measure the real SWR with the tubes, with the real tubes. Okay, we will talk about this later. Anyway, this is the original Alpha 76 circuit, which was normally driven by tubes, by equipment with tubes and P-tank on the final. When I prefer to have a tune input circuit instead of this broadband, okay, I prefer to switch tuning input circuit, because when we drive it with finals, with transistors or integrated circuit, tune circuit, input circuit, it will make their life easier. Okay, it will also reduce the distortion produced by this way of configuring it. Okay, will reduce the distortion, and also will reduce the length, the coaxial length dependency between the alpha and the driver. Okay, and the transceiver. Okay, so that's the reason I prefer to have tuned input circuit. I know that what I just said is probably will be some controversial, but it's not theory or rumors. If you have an amplifier that does not have tuned input circuit, and you could just test it, adding 1 meter of coax between the amplifier and the transceiver, and perhaps you can find out that the maximum power output could increase on some band and decrease in others. Okay, even though if you place an SWR meter in between the driver and the amplifier and measure low SWR, the output power varies. I also doubt the SWR capability to accurately measure SWR with the so distorted waveform that is playing here with this kind of circuit. Anyway, other thing that needs to be done is to modify the polarization voltage for the 3CX800s to obtain approximately 30 milliamps, 30 milliamps idle current for both tubes. Okay, what I did was just add a couple of 1 amp diodes in series with the Zener. Let's see, what else do we have? Okay. Another thing that is important is that we need to modify the warming up, the filament warming up timer, because the 3CX400 needs about 90 seconds, 1 minute and a half, but the 3CX800 needs basically the double. Okay, it's 3 minutes, 180 seconds instead. So for that purpose, you can do a couple of things. One of the things is just to, you can see here the timer is controlled by these 2 components, basically, the 3.9 megohms and the 22 microfarad, okay, capacitor. Basic mode are to add another 22 microfarad tantalum capacitor in parallel with this one. That's one way to do it. And another way to do it is I used just a 10 megohm resistor and a 22 tantalum capacitor, okay, instead of 2. The combination of these two gives the right amount of time. This one that I have is 25 volt of isolation. You can do both. Please do not forget this mode, because running the tubes earlier than necessary could seriously damage them. Okay. So, okay. We reached the point where probably most people is interested or was interested to reach, and to answer the question, which is the maximum output PEP power after the mod. Okay, so let's see what happened. This is basically my notes. The increase in output PEP power capability is interesting. It's interesting. Okay, maximum output power is happening on 160 meter band, my favorite, and declining toward the higher band. As you can see, on 160 and on 80 meters, with this drive, you could get over 2200 watt, over 2 kilowatt. As a matter of fact, one moment I had 2500 on 160. Okay, how I measure it on the PEP watt meter, you're going to have to look at it on the second video. And this is the AC voltage that I have at the time. This is without draining any current, okay, just in idle. The primary transformer probably is built for 240, but we here in this country, we have 220, fortunately. I do have a little bit more, 229, that produce a DC plate voltage of 2100 volts. And I applied this drive, the one that is on this column, with CW dots at around 25 watt per minute, more or less. Okay, you will see that on the next part, on the second part of the video. As you can see, on 160, on 80 goes above 2 kW. From 40 meters, 20, 15 meters, it goes above 1500 easily. And on 10 meters, it ran barely 1500 watt, okay? Barely 1500 watt. I think that we could work on the plate tank more closely, probably replacing, remember those interconnected wire, with wire, the one that I showed you at the beginning, with wider tapes, replacing the DC blocking capacitor for better ones, and retouching probably the 10-meter coil tap, okay? I'm confident that with all that and adding the 120 PF capacitor at the input network that we talked before, we could improve its performance on 10 meter. I didn't do it, but I'm confident that that could work, okay? Okay, folks, that's all for now. I hope that you have enjoyed this part of the video, and I also hope the information and images that I provided could be useful to you. In case you like it, don't forget the thumbs up, okay? Now we'll work on the second video, where I hope to show you the Alpha 766A, this one, on the road at full power on 80 meters. If you have any questions, drop me a note. I am okay at qrset.com. So, 73 for now. Once again, I'm Eddie, Lima United 2 Delta Kilo Tango, and I hope to meet you on the bands. Bye-bye.